Before proceeding with the declaration, understanding what is significant is crucial. The major hub is the molecule gas pedals. The collider LHC, worked by CERN, is a 17M superconducting magnet, as well as the world's biggest and most powerful atom smasher. It represents the apex of human logical accomplishment. As a matter of fact, it is so potent that it can reproduce the very states of the universe's introduction to the world. But is it possible that this machine, intended to open the mystery of the universe, holds the key to something undeniably more unpropitious? CERN, established in 1954, is one of the world's most renowned associations for research. With 23 member states and a vast number of researchers, it serves as a center for cooperation and innovation. The LHC is CERN's leading project, yet it's only one section of a huge network of gas pedals and tests. Imagine a course that isn't for cars or horses but for subatomic particles, a test of skill, endurance, and space itself. The LHC speeds up protons to almost the speed of light, sending them on a crash course that imitates the energy of the universe at the moment of the Big Bang. The impacts create temperatures multiple times hotter than the center of the sun. A large number of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 areas around the ring of the gas pedal, corresponding to the positions of 4 molecule locators: Atlas, CMS, ALICE, and LHCb. Each serves a distinct purpose, investigating unique parts of particle physics. Together, they act as giant cameras, capturing depictions of these crashes. Researchers then filter through the debris, searching for indications of the elusive Higgs boson, also known as the God particle, and other phenomena that offer pieces of the universe's fundamental building blocks. By concentrating on the microcosm, we gain insights into the cosmos. But with each answer comes another question, and with each discovery, another test. The LHC isn't just a scientific instrument, it's a demonstration of human curiosity and innovation. It encapsulates our persistent quest for knowledge and our craving to grasp the key forces that shape our universe. But as we push the limits of what we know, we must also consider the moral and existential questions that arise. What are the dangers of examining the unknown? Could our mission for understanding accidentally open powers we have no control over? In the hallowed halls of CERN, where the limits of human comprehension are constantly pushed, a discovery has emerged that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a former scientist at CERN and a voice of authority in particle physics, has recently made a declaration that has left the world both fascinated and apprehensive. Cox's words resonate with chilling clarity. The objective of CERN's Large Hadron Collider is to reproduce a small-scale Big Bang. Yes, you heard that right, a miniature version of the very event that brought forth our universe. The physicist also happened to enumerate the ramifications of this objective, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore a mysterious substance known as dark matter, which makes up a significant part of the universe. Imagine holding the power to invoke the universe's very essence. It's an enticing possibility, but one laden with risk. The mini Big Bang is not just a theoretical concept, it's a tangible reality inside the LHC. The temperatures, pressures, and raw energy all replicate the conditions of the universe's inception. It's like standing at the dawn of recorded history, observing the very beginning of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something went terribly wrong back in 1978. The Russian physicist Anatoly Bugorsky encountered a catastrophe that would forever alter his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a glitch caused his head to accidentally come into the direct path of a proton beam. The beam, with a force that defies comprehension, went through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was intense. He saw a flash brighter than 1,000 suns but had no pain. The beam's path left a trail of destruction, burning tissue and bone. Yet, he remained conscious and even walked to the center for treatment. The result was both alarming and fascinating. The beam's path caused localized tissue death, resulting in partial hearing loss and facial paralysis. But incredibly, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. This episode is not just a personal tragedy but a wake-up call that highlights the immense power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be underestimated, the potential for unexpected reactions, the very fabric of existence being altered. These are not mere science fiction fantasies, but real concerns shared by well-known scientists. One of the most disturbing and captivating concerns is the potential for the LHC's experiments to create a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are enormous vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a minuscule scale, is staggering to both the public and scientists alike. Could this black hole eventually grow uncontrollably, swallowing the Earth from the inside? Researchers at CERN have assured the public that any black hole created would be unstable and disappear almost immediately. Yet, the remote possibility has sparked discussions, fears, and a sense of wonder at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the basic mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the weight is heavy enough, it could cause such a severe depression that anything nearby would be pulled into it. This is a simplified analogy for what could happen at the LHC. In the realm of quantum physics, where the rules of the universe are both strange and wondrous, there exists a theory that extra dimensions might be hidden within our own. If these dimensions are real, the LHC's experiments could tap into them, creating a gravitational well that forms a tiny black hole. This baffling dance of particles has even captured the attention of some world-renowned scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario in which the Higgs boson might become unstable at extremely high energy levels. This instability could lead to a devastating vacuum decay, a cataclysmic event that wouldn't just destroy the Earth but could potentially obliterate the entire universe. The esteemed English astronomer and cosmologist Sir Martin Rees also expressed concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, Rees' concerns were not limited to theoretical speculation, they were grounded in real scientific discourse. While the likelihood of such catastrophic events remains low, the mere possibility raises profound ethical questions. Should humanity tamper with forces it barely understands? At what point does curiosity become recklessness? Beyond black holes and vacuum decay, another mystery lingers, the possibility of opening gateways to unknown realms. Some theorists suggest that high-energy collisions at the LHC could create microscopic wormholes, hypothetical passages through spacetime that could connect distant parts of the universe or even parallel dimensions. The notion of alternate realities has long fascinated both scientists and philosophers. If such wormholes were to form, would they be stable? Could they serve as a means of travel, or would they collapse instantly? More unsettlingly, could something pass through from the other side? Even among the most skeptical scientists, the LHC's experiments provoke questions that tread the boundary between science and science fiction. While the official stance of CERN is that these risks are negligible, there is no precedent for many of the phenomena being studied. As humanity continues to push the limits of knowledge, the unknown remains both exhilarating and terrifying. But despite the fears, the LHC has already achieved groundbreaking discoveries. The confirmation of the Higgs boson in 2012 revolutionized our understanding of mass and the fundamental structure of the universe. Research into dark matter and antimatter continues to yield insights that may one day reshape our grasp of reality. CERN remains a beacon of scientific progress, bringing together some of the greatest minds from around the world. Yet, as we seek answers to the deepest questions of existence, we must also be mindful of the responsibilities that come with such power. Are we playing with forces beyond our control? Or are we simply fulfilling humanity's destiny, to seek, to question, and to understand? Only time will tell. Theoretical musings, he assigned a low probability to these catastrophic outcomes. However, he argued that even a small chance warrants serious consideration, taking into account the enormous stakes. The margin for error is razor-thin. The researchers at CERN have run simulations, analyzed the theories, and taken steps to ensure the safety of the LHC. In fact, Brian Cox himself acknowledged the significance of this. Recognizing the widespread apprehensions and concerns surrounding the activities at the LHC, he emphasized that there are thorough safety measures in place, comprehensive reviews and protocols to ensure that the LHC's operations are conducted with the utmost attention to information. Cox assured that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so minuscule and unstable that it would dissipate rapidly in a burst of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief moment of cosmic wonder, just a glimpse into the abyss, and then gone. Some have gone further, theorizing that the LHC's experiments could open a gateway to a different dimension or universe. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many and become a subject of interest, fear, and even myth. What lies beyond our universe? Could we accidentally release forces or entities that we don't understand? The notion of opening a door to hell has even been sensationalized in various media, fanning the embers of doubt. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they might theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key unlocking doors that have been sealed since the dawn of recorded history. When protons collide at energies never before achieved on Earth, they could, in theory, create waves or ripples that probe these hidden dimensions. If these dimensions exist, the LHC could potentially reveal them. But before we get carried away with wild speculation, it is essential to comprehend that, even though the LHC is undoubtedly powerful, there is no definitive proof to suggest it will open a door to another universe, let alone hell itself. Nevertheless, the allure of the unknown, combined with the enigmatic nature of quantum physics, means such ideas will continue to captivate the public imagination. So, should the LHC be of concern to us? It's easy to be swept away by sensational headlines and fears of cosmic catastrophe. But the truth is, the scientists at CERN are well aware of the risks involved. They have taken every precaution to ensure their experiments are safe, and they continue to monitor and assess their work with the highest level of diligence. The research's potential benefits, the breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly extraordinary. Not just a demonstration of human ingenuity, but a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the forefront of scientific research, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. But in spite of stringent safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it generates is awe-inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of LHC experiments, there are obvious uncertainties. What if new, unexpected phenomena emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world. As the collision of particles recreates conditions not seen since the Big Bang, the profound nature of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nevertheless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened opportunities for future innovations that have the potential to alter our technological future. Despite the risks, the pursuit of knowledge remains one of humanity's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC is no exception. Its experiments delve into realms of physics where intuition no longer applies. For decades, physicists have tried to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a crucial role in the structure of matter. The discoveries made at the LHC have been instrumental in providing clues that bring us closer to a unified theory of everything, where all these forces may be reconciled under a single framework. As humanity continues to explore these frontiers, the very nature of these experiments has raised profound ethical questions. Could advances in particle physics lead to unintended consequences for our planet, or even for the fabric of reality itself? These are difficult questions that need to be answered with careful thought about the broader implications of scientific progress. For example, the creation of exotic particles or the study of high-energy conditions might reveal hidden aspects of the universe, but they also carry the risk of triggering new phenomena that are difficult to predict. As we venture further into the unknown, we must ask ourselves, what are the ethical and philosophical boundaries of scientific exploration? Should we pursue knowledge at any cost, even if it comes with uncertainties we cannot yet fully comprehend? History has shown that major scientific advancements often come with both extraordinary progress and unforeseen consequences. The discovery of nuclear energy, for example, led to both revolutionary power generation and the devastating potential of atomic weapons. Similarly, artificial intelligence is rapidly advancing, bringing both remarkable innovation and ethical dilemmas. The LHC, while a tool for understanding the most fundamental forces of nature, is no exception to this duality. It stands at the crossroads of human curiosity and responsibility. The scientific community has the duty not only to push the boundaries of knowledge but also to ensure that such pursuits are conducted with the utmost caution and foresight. Public perception plays a significant role in shaping the discourse around such powerful experiments. While scientists meticulously analyze risks and establish safety protocols, sensationalized media coverage often amplifies public fears. The fear of the unknown is a natural human instinct, and the idea of manipulating forces reminiscent of the early universe is bound to spark both awe and apprehension. Despite this, it is crucial to acknowledge that scientific progress has always been driven by taking measured risks. Without it, humanity would not have made the strides it has in medicine, technology, space exploration, and countless other fields. The pursuit of knowledge has propelled civilization forward, uncovering the deepest mysteries of existence. In the case of the LHC, it is not just about satisfying intellectual curiosity. The research conducted at CERN has real-world applications, from advancements in medical imaging and cancer treatment to improvements in data processing and quantum computing. The technological spin-offs of high-energy physics research have far-reaching impacts beyond theoretical discoveries. Looking ahead, what does the future hold for the LHC in particle physics? Scientists are already discussing the next generation of colliders, machines even more powerful than the LHC, that could unlock deeper layers of the universe's fundamental structure. Projects like the Future Circular Collider, FCC, and the International Linear Collider, ILC, are being proposed to continue the search for new physics beyond the standard model. Yet, as these plans unfold, the same questions will persist. How do we balance scientific ambition with ethical responsibility? How do we address public concerns without stifling progress? And most importantly, how do we ensure that the pursuit of knowledge remains a force for good? The Large Hadron Collider, with all its grandeur and mystery, is a testament to human ingenuity. It represents our unyielding desire to understand the cosmos, to peer into the depths of reality and unravel the secrets of existence. Whether it ultimately reveals new dimensions, uncovers unknown particles, or simply refines our current understanding of physics, its legacy will be one of bold exploration and boundless curiosity. As we stand at the edge of discovery, one truth remains certain: the universe holds mysteries far beyond our comprehension, and our quest to understand them is what defines us as a species.